What is up, guys? Steezy here, bringing you another, I guess, particle effect tutorial. In this one, I'm going to be teaching you a bit more about the math I've been using in my tutorials, since a lot of you don't understand it very well. Before I get started, I just want to tell you that I'm recording this on my phone, and it is actually duct taped to a lamp, which I think is hilarious, and it's pretty frickin' sketchy, but it seems to be getting the job done. So let's get right to it here. So I'm going to start off just showing you the sine function, y equals sine of x, and the graph of that looks like this. So we have, it starts at 0, goes up, back down, and then to 0 again. And this is one cycle, which goes from x equals 0, this is the x-axis, it's y, goes from 0 to 2 pi. Where pi is just equal to the number 3.14 with infinite digits after that, but just think about it as a number close to 3.14. So this is at pi. It has a maximum of 1 when x is equal to pi over 2, and it has a minimum here of negative 1 when x is equal to 3 pi over 2, which is just 3 times 3.14 divided by 2. It just is that number right there. Next is the cosine function, which is very similar to the sine function, except it starts up here at when x is equal to 0, y equals 1, and it's going to go down like that, and then back up again to 1, and has a cycle or a period of 2 pi, just like sine. This point here is pi, the x-intercept is pi over 2, this is 3 pi over 2, and you can see that the cosine and sine are very similar. The only difference is that the cosine is basically shifted over by an angle, or x, of pi over 2. So if we take this and we move it over here, we could see that this is actually a cosine function right here, and this actually continues forever, but we're just looking at from 0 to pi over 2. So that is the sine and cosine function, and these functions are, we have y is a function of x, meaning given a value of x, we're outputted a value of y by taking the cosine or sine of it. What a parametric equation or parametric functions are, parametric equations are, we have x and y are both a function of t, where t is the changing input variable, and that gives us different outputs of x and y. So for example, the parametric equation of a circle is x is equal to the cosine of t, and y is equal to the sine of t. And these two parametric equations combined together will give you the equation of a circle. And so if we want to plot this circle or make a graph of it, what it would look like, we could draw let's use a table to help us out. So we'll have t is our input here, and then we'll have our output x and y. So when the value of, so we're going to use values of, let's do 0, pi over 2, pi, 3 pi over 2, and 2 pi. When we plug in these values of t or these values into t in our parametric equation, we're going to be given new positions or new coordinates x and y, depending on the value of t. So when we plug in 0 for cosine, if you don't know what that is, we could look at our graph here. We have y equals cosine of x. So when we plug in 0 for cosine, we have an output at 1 here. So this value is going to be 1, and then when we look at y, this is the parametric equation for y is sine of t. So we look at our sine graph. when t equals 0, we have 0 because it's right at the origin there. So we have our first point when t equals 0 in our parametric equation, we're going to get the point 1, 0. So if we want to plot this, plot our parametric curve here, our first point is going to be at 1 and 0, where this is x and that's y. So that's our first point, and this point occurs when t is equal to 0. The next point, we can plug in pi over 2 for an x and y here, and we will get, if we look at our functions, we have that is at 0 and that is at 1. So we have 0 and 1. And the next one is pi. Here we have -1 and 0. And then 3 pi over 2. You can see we have 0 and -1. And then finally 2 pi. Since the period of the function is equal to 2 pi, it's going to end where it starts again. So we're going to have the exact same output. For example, here we have 1 and 1, and this is 0 and 0 again. And just like in the first line when t equals 0, it's going to be exactly the same. It's also going to be 0 and 1. And then this will keep repeating as t gets larger. The next value is going to be 0, 1, and then -1, 0, and it's going to keep repeating over and over because it's a repeating function. So we can plot the rest of these points now. So we already plotted 1, 0. Now we'll plot 0, 1, which is right here, and that occurs when t equals pi over 2. Next one is -1 and 0, or yeah, -1 and 0, and that's when t equals pi. And then here we have this is at 0 and -1 when t is equal to 3 pi over 2. And then the last point is right where the first point was, where t is 2 pi. So what if we used here we used an interval of pi over 2 just to get some points. If we used a smaller interval, say pi over 4, we would end up with when t equals 0 there would be a point there. When t equals pi over 4 it would give us a point there, and then the next one here, the next one there, there, and there, and that will make a much clearer circle. I was just too lazy to go through all of them. So if we use an infinite number of points, we will get a nice perfect circle starting when t equals 0, and as t increases, it'll go around like this till it's pi and continue all the way to 2 pi. And if t becomes larger than 2 pi, it's just going to keep creating the same exact circle over and over forever. So that's how kind of basic parametric functions work, parametric equations. So now in terms of Minecraft and particle effects and the math I've been using in that, in Minecraft, here let's do a helix for example. So in Minecraft, y is in the vertical. So parametric equation is cosine x equals cosine of t, y is going to be equal to t, and z is going to be equal to sine of t. So the cosine and sine is going to make the circle here, which we just saw, in the xz plane, meaning it's going to be horizontal or flat. And since y equals t, as time increases, y is also going to increase. So it's going to, we'll draw this again. So now this is x and this is z instead of y. And the y-axis is going to be out of the, pretend it's coming out of the page like this. I know it's hard to visualize, but do your best. So we're going to start when t equals 0 is our first point, and normally in my code I'd have a runnable, so we'd start off like t equals 0, and then each time it runs through the loop creating a new particle effect, we're going to increment the value of t by t plus, say, let's do math.pi, or pi, divided by, say, 8, because that'll give us a much nicer looking particle effect. So this is when t equals 0, and then we're going to loop through, create that particle effect, and now t is going to increase by pi over 8, and it's going to create the next particle effect given the parametric function. So the computer plugs in pi over 8 for cosine, or in the cosine function, and t and sine. So the next point will be about here, but it will be a bit out of the page, or in the y direction. The next point will be even higher up on the next point in the circle as well, and it'll continue going higher and higher until it makes a nice helix looking shape. I know it's really hard to explain on paper, maybe I'll put in a clip here. So as you can see here, we start off at t equals 0, and it goes all the way around. Now it's going to approach 2 pi right here, and it's going to continue going after 2 pi. And now here I just made it faster using a smaller interval of t. As you can see, the value of t is increasing much faster, or it's updating much faster, but it's increasing by smaller amounts each time, meaning there's going to be more particles along each arc, or along the arc of the helix, or the circle it's creating. So it starts at 0, goes around 2 pi, as one loop, and it keeps going. So that's 2 pi, now it's 4 pi, now 6 pi, 8 pi, and so on. But yeah, so that's how you make a helix using parametric equations. If you want to find other cool things to make, you could go on Google or Wolfram Alpha or something and Google parametric equations, or parametric equation of a sphere, or a whatever, or a cone, maybe, whatever you want to make, and they'll give you a parametric equation in terms of x, y, and z as a function of t, or maybe it'll be given in 2 variables if it's a surface. So I think that's all I wanted to talk about. Thanks for watching, hope you enjoyed. Let me know if you would like more explanations of the math. I feel like you won't, and this is probably extremely boring, but thanks for watching. Leave a comment, and I'll see you next time.